di farlo un po' all'inizio di questa presentazione. Chi di voi qua sono operatori di bus non già coinvolti nelle operazioni dei fuel cell bus a Riviera Trasporti? Magari possiamo vedere un po' di conferme. Nessuno coinvolto nell'operazione di bus nelle altre autorità pubbliche? Sì? Ok, e magari le autorità di trasporti o magari anche assessori di città vicini interessati, così abbiamo un'idea anche perché su cui focalizzare i dettagli nelle informazioni che sta presentando adesso. Ok, grazie. Yes, I asked a bit who was involved in the operations of buses here in the neighborhood, but I think we have a lot of interested people, but maybe not many specifically interested in the more technical details that we have also included in the presentations. But we leave the presentations here, so we make sure that they are available in case any of your colleagues might want to go over them. Okay.
Shall I go over the key benefits?
Yes. Yeah.
So
go ahead.
I will just go over some of the key messages that we have on hydrogen buses, some of which will be similar to discussions that have happened earlier today. So the core benefits of operating hydrogen buses: zero emission, and by this we mean only water emitted from the exhaust. In London in particular, we have seen this is vital for air quality as well as for CO2, reducing CO2 emissions. So this is also a particular concern, for example, in Bolzano and Milan as well. Unlike trolley buses, they require no overhead infrastructure, so there are benefits for being able to offer a zero carbon technology without changing layout of cities. And the new buses have a great fuel economy. We see a massive improvement on the previous buses. And we also see availability beginning to become close to the conventional buses in the field. This slide just shows you that where we have come from. In the CUTE project, we had an efficiency of over 20 kilograms per 100 kilometers, and we have drastically decreased the amount of fuel that's required per kilometer traveled by almost a factor of by more than a factor of 2 within the current trials by using hybrid buses. As you can see, this also translates into range. So the increased fuel economy or improved fuel economy also allows us to have the range we require, and the availability the availability figures are beginning to become within the bounds of what you expect for new vehicles, and particularly comparative to diesel hybrid. And the last point to mention is refueling time. All of the Chic projects have targets for less than 10 minutes per bus for refueling time, and these are being achieved in several of the cities. Typically, it's certainly no more than 15 minutes per bus refueling time. And finally, on the capital costs, this is one of the main issues that is outstanding with the fuel cell buses that we see today. We have some historical data here collated that shows how much progress we have made since the early 2000s on the capital costs, but it is still much higher than the cost of a conventional diesel vehicle and even a conventional diesel hybrid. So there is still further progress to be made towards the cost targets. When we look at when we interview the industry and ask the component suppliers and the bus suppliers where they think they can get to, they look to try and make a vehicle which eventually reaches parity with a diesel hybrid bus. So But all of this requires both volume effects and also learning effects from engineering. I think. There are some detailed studies which I will not go through now, which include a study called Next Highlights that was done for the European Commission, which break down the costs of all the components for the hybrid buses. And you can also download this online and find it in the information in the presentation pack as to where to find this document. So, to conclude, the high cost of the buses is really the key barrier at the moment to future commercialization. At the moment, we still have a factor of 5 to decrease the cost towards the conventional vehicle bus. Overall, the costs are dominated by the fuel cells, which require volume in order to reduce the costs. However, the costs are projected to rapidly decrease through time as the fuel cells hit market production and can be manufactured on production lines. This is also impacted by future plans for fuel cells in the passenger car market. With planned cost reductions, fuel cell buses can achieve a plausible cost competition with trolley buses before 2020 and with diesel and diesel hybrid buses in the 2025 period. So, the final comment to make is that technology, as I mentioned, the technology requires volume to reduce the purchase cost. The one option that we have looked at as a group within the Hydrogen Bus Alliance is to look at joint procurement to increase the volume of buses purchased. And this we found from interviewing industry could significantly reduce the costs. So this is another option to look for moving forwards. Thank you for your attention. Now we have some videos.
Thank you, Kate. Ci sono qualche domande a questo punto della presentazione? Perché abbiamo, come detto, ancora qualche riferimenti a dettagli più precisi. Sì? Sì. Va bene, sì.
Allora, considerato che ormai il differenziale di prezzo come carburante tra il diesel e l'idrogeno è molto molto vicino, il gap costo per 100 km percorsi da un autobus a idrogeno, un fuel cell e 100 km fatti da un diesel a prezzo italiano ovviamente, non nord europeo, si sposta di non più di 4 o 5 euro su 100 km. Il vero problema è separare il discorso della produzione del carburante da quello che è l'operatività dei bus. Cioè, l'idrogeno deve diventare un qualsiasi carburante per mezzi di trasporto. Questo deve essere separato da quello che diceva Miss Harland, che è interessantissima l'ultima slide. Quello che separa la competitività dei bus ad idrogeno da un diesel o da un hybrid bus è semplicemente il numero di autobus prodotti, perché il prezzo si abbassa in maniera esponenziale sulla base del numero di pezzi prodotti. Quindi sarebbe opportuno che chi vuol promuovere l'idrogeno, l'Unione Europea o altro, investisse essenzialmente sulla diffusione degli autobus, perché il sistema di produzione è ormai indipendente del carburante. Si può giocare su mezzo euro, 50 centesimi, un euro ogni 10 kg di idrogeno, non di più. Quello che sposta il problema sulla competitività economica del fuel cell è il numero di pezzi prodotti. Quindi sarebbe opportuno spingere su una diffusione e un'elevazione e contribuire a creare una massa critica di produzione di bus tali da consentire un raggiungimento di un prezzo intorno ai 700-800 mila euro, non di più.
No, I think Kate Mr. Corrado, who is actually the initiator of the bus project here in Imperia, in Liguria, for the high velocity project, is referring to the indeed still very high cost of the buses. We have seen in previous presentations also that the cost of hydrogen becomes more comparable to the one of diesel, so that there probably the problem is not so much as eminent as the one on the price of the buses. And because we still see smaller numbers at this stage, for every transport authority it will be difficult to decide on bigger numbers. So he is asking a bit what could be done at EU level to speed up the numbers according to you and your experiences.
Okay, thank you. Perhaps I can have one slide put back on. Yeah, that'd be great. Okay, so one comment I think is that within any new bus project, new technology, there is a significant risk that is taken on by the manufacturer and the supplier. So you see a difference between when you interview the component suppliers and when you ask the bus supplier for what the cost of the vehicle would be. And this is basically around technology risk and one-off engineering design costs. So this is the green shaded area on these charts, which I think we can agree will disappear if we can get significant volume into the market. So that is one aspect. From an EU level, I think it's basically about stimulating volume. The costs are too high at the moment for anyone to consider more than a trial of buses on their own municipality or their own organisation. And it's really about pulling people together, decreasing the costs so that there can be a subsidy or an equivalent which could, in the UK we have something called the Green Bus Fund for diesel hybrids, for example. Some similar situation for hydrogen vehicles. If we can get the costs within a similar premium that is acceptable, then that type of initiative I think would help drive volume and drive costs down for the industry. But I think there needs to be very clear signals from both sides, from the politicians and also about what they might offer, and also from industry about what cost targets they really can achieve on this. The big point here is there are two different strategies. One is bus-based and one is linked to passenger cars. The bus stacks, you can have a very long lifetime fuel cell, which is very reliable and doesn't require changing on a very frequent basis and is designed specifically for bus operation. The other idea is to have lots of passenger car stacks put together. And the second strategy requires support for a passenger car market as well. And that would also decrease volume and also introduce some competition into the market. So it depends which strategy the technology goes down. But I hope that answers your question, at least or goes some way to answering the question.
Any more questions? Di più? Sì, prego. Magari si vuole introdurle anche, sì. Le sento, però non so, le altri, sì.
Qual è il tasso di guasto e quali sono i componenti più critici di questa tecnologia? Responsabile manutenzione antigen.
Ah, ma certo. Sì, grazie. Kate, this is the responsible person for the technical operations at the Transport Authority here in Imperia. And he had a question indeed on the collection of data and the experiences on the performance of the different components. What is doing well and what is doing less well in these buses?
This is a good question for me to answer because I spent lots of time with the operation of the buses. So, in London, we see surprisingly few problems with the fuel cell. The problem really on the fuel cell is that sometimes when we have a problem, because the supply chain in the UK is not very big, and because you need specialist people, the time taken to fix a problem is longer than you would expect for normal diesel vehicle operation. But actually the number of problems is quite low. And one of the problems which has recurred across lots of cities, we don't have batteries, but other cities have had significant problems with their battery systems or their hybrid systems. We have also had problems with some components in our hybrid system, but we have ultracapacitors and not batteries, so we haven't had any battery problems, apart from with 24-volt batteries. The interesting thing is you actually find quite a lot of problems between the interface with the normal bus, systems you expect not to have any problem with, and the fact that you've introduced a new technology. So we actually had some initial problems with steering and things which are quite easily, and heating is another issue which are normally quite standard, but because you have changed the system and you've designed a new system on a one-off basis, we have had some problems there. But overall, I think it is good news for the technology that the main drive component of the vehicle has seen relatively few problems. So, and we have some buses which operate 28 days without fault, so between inspections.
Ok, sì. Altre domande? Sì, prego.
Volevo solo chiedere...
Scusi, il suo nome?
Sì. Sono Ginanneschi di Bus to Coach, un website. Volevo solo chiedere questo. Dal vostro punto di osservazione, come definireste lo stato di avanzamento della tecnologia delle fuel cell? Cioè è uno stadio semi-maturo, ancora molto sperimentale, o è uno stadio di prodotto maturo? Ecco.
Sì.
E se non è maturo, quanto ci vorrà perché le fuel cell possano avere un'affidabilità e anche un'evoluzione tecnologica tale da essere effettivamente dei componenti affidabili e risolutivi di problemi, che so, di ingombro piuttosto che di capacità di potenza.
Sì. No, direi che ovviamente l'esempio di Londra, e poi lascio la parola anche a Kate, con adesso 4 bus in servizio giornalieri nel centro città di Londra, così sono messi in servizio come tutti gli altri bus a Londra, dimostra già la fattabilità e la qualità delle pile a combustibile ovviamente, però direi ci sono specifici anche per la durata di questi stack del fuel cell che ovviamente pesano ancora sul prezzo. Kate, the question is, what is the state of current fuel cell technology? Are we close to commercialization in that it has reached the state of the quality that we are used to in power systems, or is it still in an R&D phase?
Okay. So I think I can say that we have 15,000 hours warranty in London. So this is the warranted lifetime of the fuel cell, which allows us at least to operate for around 4 years in the London operation. And that is, for us, acceptable. Obviously, it needs to increase a little bit further to reach commercialization. So that is, in terms of lifetime, I think we are getting there. In terms of reliability, I think we are also at a state where the fuel cells can do. They can run for 20 hours a day, 7 days a week, and for a period of time without having significant problems. One thing I think requires more work is the supply chain and the expertise and the training around being able to maintain the fuel cells so that when there is a problem, it is fixed quickly. Because our diesel vehicles, in the depots in London, we expect to be fixed overnight, when in a 4-hour window often. And that is not possible at present with the technology and the levels of training that we have for local staff. So I think training and development of supply chain is an issue to be resolved as well. But generally, we've been pleased with the fuel cells in London.
Yep. Yes, thank you. Altre domande? Sì.
Grazie. Sono Stefano Rampini della società Rampini. Non so se l'intervento che sto facendo è coerente e logico in questo momento, però, dato che noi produciamo un autobus a idrogeno da 8 metri, as we produce a bus 8 meters length, vorrei sapere se nel progetto CIC ci sono limitazioni, colpa mia che non l'ho guardato bene, però ci sono limitazioni, ci si può accedere, si può lavorare anche con queste dimensioni, tenendo conto che soprattutto nel nostro mercato, nel mercato italiano, noi abbiamo tante piccole città, tanti centri storici, tante zone dove il 12 metri ha dei vantaggi ma anche degli svantaggi. Prima cosa. Seconda cosa, in merito al discorso dei costi e al discorso dell'abbattimento, è chiaro che non solo il discorso della fuel cell, che è la più pesante nel costo, incide, ma indiscutibilmente anche avere una base di autobus come l'abbiamo noi, su cui facciamo diesel, full electric e idrogeno, indiscutibilmente ha i suoi vantaggi. Quindi è giusto perseguire alcune strade, ma è anche giusto non dimenticare che se anche c'è anche una componentistica che pesa meno nel costo totale, anche quella lì contribuisce a determinare un costo totale. In merito all'esperienza, noi abbiamo l'autobus che ormai gira da 5 anni, quindi anche noi ho 5 anni, però noi l'abbiamo sempre portato avanti in termini di test interni, test nelle piccole città, test seguiti. Adesso segue? No, non ha messo la cuffia per l'italiano. Adesso sta seguendo?
Yep.
Ok.
Sì.
Ci pensa lei a ritradurlo? Lo faccio io?
No, credo per la seconda parte devo ancora capire un po'. Magari io potrei riferire alla prima domanda e poi magari facciamo la domanda più diretta a Kate per la seconda parte.
Come vuole.
Per la prima parte direi che sono stata coinvolta me stessa l'anno scorso in creare un consorzio sui bus a queste dimensioni piccoli per una proposta per lo stesso bando che ha seguito anche High Velocity, per creare un progetto bus per i piccoli dimensioni, soprattutto per le città e le comunità che descrive lei. Credo che ci sono limiti per queste proposte, per questo programma europeo sui bus. Peraltro dobbiamo anche dire che questi programmi sono scritti dall'industria, che si aderisce al programma come cofinanziatore da parte della Commissione e governi e regioni, per arrivare al budget del 900 milioni di euro, 940 milioni di euro per questi 6 anni, che in questo caso i fornitori dei bus non sono così presenti in questa associazione di industrie che segue questo programma. Così la visibilità di queste applicazioni, non è così grande come i bus. E è anche vero che dobbiamo arrivare ai numeri. In caso dell'anno scorso, in cui abbiamo provato di cercare qualche località, soprattutto anche in Italia, erano in Trento, in Veneto, la Lazio era interessato. Così ci sono realtà che potrebbero cercare anche con più forza la visibilità in questi programmi europei. Devo dire, per Chic è già concluso il consorzio, perché questo già da 2 anni ha il suo budget e ha le sue attività definite. Così nell'ambito del progetto Chic non vedo tante possibilità di far inserire un'altra località e altri bus. Però questo bando che scade il 24 maggio, poi quello dell'anno prossimo si potrebbe immaginare, e noi come Associazione delle Regioni stiamo anche facilitando questi consorzi per arrivare a ulteriori progetti bus con altre dimensioni. Sì, ok. Sorry, Kate. The first question was also on the, yeah, that was a bit more towards the smaller buses. But magari la seconda domanda possiamo fare, sì.
Can you hear me?
Yes.
Okay. So the second question is this one. As far as the cost of the bus is concerned, of course, the fuel cell is the main component. I can understand. And if we can reduce the cost of the fuel cell, we are able to reduce the most part of the total cost of the bus. But in the meantime, we have not to forget that there are also a lot of other components that are part of the bus. So our experience is this one. Maybe you have lost the first part. I will remind you that we produce an 8-meter length bus, but we produce not only, sorry for my bad English, but I hope you can understand.
I can understand it perfectly.
Okay. So we use the same base for the diesel bus, fuel electric bus, and hybrid hydrogen bus, so that we can reduce the cost on the main components. And of course, the cost of the fuel cell is, let's say, standing alone, something like this. So it's not depending from us. So this is also another way for reducing the cost. The last one, as far as our experience is concerned, we have now more than 10,000 hours experience with our bus, but up now we have not yet sold anything. We have sold electric buses, but not bus with hydrogen, just because before coming into the market we want to be sure. And
this is really important, I think, particularly for a consortium-based approach, that operators have a reliable product when they start, so not to put off future projects as well, not to put people off. Sorry, no, keep going.
No, I agree entirely.
Yeah.
I don't have any problem, because this is what we have already done, both in the electric and in the hydrogen. And as far as the maintenance is concerned, I can confirm that our experience is positive, because I told you that we have the bus now running more than 10,000 hours, and we have had just minor failures, but not on the hydrogen or on the batteries. Just the standard failures of a normal bus.
Yeah.
Thanks a lot.
Thank you. We too have had more problems with classically standard components which have been around for a while, and maybe they're just not used to the operating characteristics, but they seem to have problems with conventional parts. Yeah.
Magari teniamo le domande anche dopo, perché Kate Harland sarebbe anche disponibile dopo questo incontro per domande più precise. Vorrei invitare Kate di procedere alla prossima parte del workshop. Grazie. Yeah? Could you continue the
video?
presentation?
Is that okay?
Yeah.
Okay, so now I have a short video to show you of the buses in London. We also have one for Cologne as well. So 1 minute. I think.
Well, maybe you need to put the microphone a bit close to the... Yeah.
When I was a teenager, I used to read a lot of science fiction. And if I'd read then that there would be a bus that ran on gas and produced nothing but water, I'm not sure I would have believed it in my own lifetime. And yet here it is. And it says a lot about London and the forward-looking of London, the fact that we're willing to embrace future ideas and put them into practical operation. So we've got this bus.
This is our main.
This is one of the new zero-emission hydrogen fuel cell buses. It's unique because the only emissions from it are water vapour, and it is one of the cleanest buses.
I can do the voiceover. The pictures you have been seeing
everything
are
from where transportation really should be and will be going here in the near future.
TfL runs the largest bus fleet in Europe. We have 8,500 buses, and over the last 10 years or so we've been doing a lot of initiatives to make sure that the diesel fleet is as clean as it possibly can be. But I think it's also important, as the operator of a big bus network, that we also look to future technology.
This bus has no engine. It actually has a fuel cell which combines hydrogen and oxygen to make water and electricity. And it also has an energy storage system so that it can be stored and used when it's needed most, when you're accelerating or when you're going uphill.
The concept takes in compressed hydrogen stored on the roof in hydrogen cylinders and takes in compressed air. It's injected into a fuel cell module which is stored in the back of the bus, and the output is electricity and water, pure DI water. That's the only emissions. The electricity is used really for the drive motors, which directly couple to the drive shaft and propel the bus forward.
Londoners travelling around seeing this bus will see a very clean bus, a quiet bus that only emits water vapour or water from this exhaust. The water is clean enough to drink, it's pure water, it's like this.
This is a purpose-built hydrogen refuelling facility for TfL's hydrogen buses. It has a number of safety interlocks and features on it that allow for safe fueling of not only the buses, but also any other hydrogen vehicles that TfL wish to bring to the facility.
What passengers will notice when they're on the bus is they're a lot smoother than a conventional diesel bus, and they're also a lot quieter than a conventional diesel bus. So there are some additional benefits apart from being very, very environmentally friendly. They're also smoother and quieter for the travelling public.
I think the acceleration and braking technique on the bus is going to benefit passengers with regard to the smoothness.
I think this is a great bus, and it's very quiet and very comfortable to drive. I think the public is going to love it.
They'll be running throughout the day, backwards and forwards, very, very high-profile route. So absolutely, not only will Londoners see them, but a huge number of tourists will see them, and we'll see that London is leading the way on hydrogen in Europe.
We're working with several other European cities who also are deploying hydrogen buses in their fleet to share our experiences to make sure we get the best learnings for everyone.
It's a great place for this technology. These buses are fuel cell hybrid vehicles, so when you're dealing with very much a stop-and-go type of transit, which is very much prevalent in London, these buses are going to be highly efficient.
London should be proud that it's actually using some of the most advanced technology in its bus fleet and is prepared to trial this technology and bring it to the streets of London.
It's absolutely vital also that London leads the way with this kind of technology. You know, we have a huge centre of excellence here for science and development, and we want to showcase some of these technologies so that the rest of the world can come and see them and invest here for the hydrogen future.
So that's our public video. You can see it on YouTube as well, for communicating with the public. And you will also have seen one of our politicians there, the Deputy Mayor of London, trying to get political support for hydrogen in London. You will have heard his comments there. So I'll show the Cologne pictures as well.
Well, maybe we can do that at the end of the presentation, and we show the website, and we can conclude with the Cologne video. Yeah, so we continue with...
we move on to infrastructure.
Yeah, the hydrogen infrastructure part.
Okay. Okay, so I'm presenting on behalf of my colleagues who couldn't be here to talk about the infrastructure for the buses. Every hydrogen station is composed of basic components which include, first of all, an on-site hydrogen storage system and an on-site refueling system. The storage is typically based on either a gaseous or liquid hydrogen technology, and then you can have varying degrees of numbers of compressors and intermediary tanks and numbers of dispensers to take the hydrogen from the storage and refuel in the on-site refueling system. I will give you some very specific examples later of, for example, the station in London and also the station in Frankfurt. If the hydrogen is also produced on site, you also need to have the hydrogen production equipment. So this, for example, in Sheik includes Milan, who have an on-site electrolyzer, and they use their renewable electricity to produce hydrogen using electrolysis. Hydrogen can be supplied from various ways, and this is one of the advantages of hydrogen as a fuel, that we can use it both, not only derive it from natural gas, but also use on-site electrolysis and derive from the grid to generate renewable hydrogen. Overall, hydrogen is well established as a fuel in the industry and has been transported for many years. It is just new that it's being implemented into transport. And for the largest volumes, there are already existing hydrogen pipelines. But most commonly for transport projects, if it's a large volume of hydrogen which is required, it's delivered by liquid hydrogen. And if it's a lower volume, then by gaseous tube trailer is typically common. And here there are three pictures. The one in the middle is actually the London delivery liquid tanker. And then on the left-hand side, you have the gaseous tube trailer from another city. The largest refueling station we have in Sheik is the Whistler BC Transit Station, which can refuel up to 100 kilograms or 1 ton of hydrogen per day. And you can see very significant on-site storage pictured in the photographs. They basically need lots of on-site storage because of the situation in a mountainous region where avalanches, etc., can block the traffic and block the road. In Europe, we're about to have a very large refueling station in Hamburg, which will be able to refuel up to 750 kilograms of hydrogen per day, and will be supplied by hydrogen produced from water electrolysis. It is going to be able to refuel buses at 350 kilograms and also cars at 700 bar. This is an important distinction that exists today, that most buses operate at 350 bar, and most cars at the moment are planned to operate at 700 bar. The cost for a bus station can be reduced by only needing the 350 bar station, but in order to be compatible also with cars and other public vehicles, then 700 bar is required in many cases. But 350 bar really substantially reduces the costs, the capital costs of the equipment, by a factor of 2, for example, at least. So that there's clear advantages to having a depot-based 350 bar station. In this case, Hamburg has gone for a public facility as a showcase. It's not only the refueling station which needs to be considered when deploying hydrogen bus projects. The other aspect is good planning of the depot, and as I've said, it often makes sense to have refueling on site at the depot for traditional bus operations. The depots need to have several characteristics. They need to, at the moment, have rooftop access, because most of the maintenance will take place on the roof. So here we've shown some access cranes. In London, we actually just have some step access and harness systems. But this is still, the practical considerations of operating hydrogen buses means that the depot design needs to be considered, or depots need to be modified to suit the operation of hydrogen vehicles. And the other two important features are gas detectors to detect the level of hydrogen and the flammability level. We have sensors at different lower flammability limits in London. And the other aspect is a hydrogen ventilation system. This can be planned to be a natural ventilation system, or in some cases you will have, in the UK, for example, we have had to install some mechanical ventilation. But this is very much dependent on local legislation and local rules at the moment. So this has been a barrier, I think, to wider scale rollout moving forwards. We need to have a consistent strategy as to what depots need for consistent hydrogen bus operation. As I mentioned before, the renewable energy can be used to produce hydrogen for the fuel. In Milan, for example, they have taken the opportunity to put solar panels, PV panels onto the roofs of the parkings around of the vehicles, and also on the side of their main building, which means that they will use about 30% of their power from their electrolyzer will be green from their on-site photovoltaics, and produce their own hydrogen. Here are some pictures you will have seen also in the film of the detail of the London hydrogen station. In particular, we have, right in the background, there are some 500 bar storage tanks. We have a very simple design in London. Almost everything is mobile and is situated on the trailer which comes to deliver the hydrogen. All we have on the ground is a bank of storage tanks at 500 bar, and the buses are fueled by what is called a cascade system. So there's no on-site compression. It is all a cascade system from the 500 bar storage to the 300 bar, which is 350 bar, which is required up maximum in the bus. And this keeps the capital cost of our station low, and also keeps the kit transportable between other stations and locations. So that's why in London we have this option. And as a specific case, I mentioned in the London depot, we have the step access. So you can see in this picture just the basic inside of our London depot. You also saw it on the film. And as I've mentioned, the adequate ventilation and sensors have been installed in this depot. We have 2 bays for maintaining the vehicles in London. To maintain 8 vehicles, but up to 10 would be, or 20 would be sufficient to have just 2 bays. But it is a dedicated building for the hydrogen buses in London. In contrast, you see the Egypt station in Frankfurt. This is this is a publicly accessible station rather than the London case, where it is solely based on the depot of the bus operator, and mostly we have no public people visiting the site unless by arrangement. So in Frankfurt, the volume dispensed can be up to 800 kilograms per day, and you can see there are three dispensers, and the price there is higher than the London example, where we have the very specific contract for bus operations at 10 euros per kilogram. But this station has been in operation since 2006 as well. So it's a time factor. Very recently, last year, the Cologne bus, the APTS bus, 18-meter bus, did a trip from Cologne down to Frankfurt to see how far they could travel and where they could visit on the day. And they managed to stop and refuel at the Frankfurt station successfully. So there's just some images here to show that the bus, the 18-meter bus, can refuel in Frankfurt. So there you go. The bus refueling. Okay, so what are the outstanding issues for hydrogen infrastructure and hydrogen maintenance facilities? Hydrogen price at the pump is actually, as Marika mentioned earlier, it's closer to the diesel equivalent than the capital cost of the vehicles. And if you have a very long contract or a very large volume, you can get quite close to euros per kilogram, which is equivalent to diesel in terms of cost per mile basis. In London, we have achieved this by having the fleet we operate. We don't have much of a cost premium for our hydrogen fuel. But this very much depends on volume and length of contract. And also how much money you put up front to help with the capital costs of the refueling station. In general, for wide-scale rollout of hydrogen vehicles, the cost of hydrogen does need to be comparable or less than diesel fuel. And as I mentioned, this can be achieved in some circumstances. But one important characteristic is whether you achieve the price and you achieve green hydrogen. In general, the green hydrogen production, particularly in some on-site situations, can be more expensive to produce. And the challenge really is to meet those two requirements in one: cheap hydrogen or affordable hydrogen, and keeping it within a green hydrogen pathway. I think there are two main issues which need to be addressed in general for hydrogen infrastructure. In urban centres, there is an issue around land availability, particularly if you have space constraints that are put in place by safety distances, etc., and you have liquid hydrogen being involved. And then this leads to, I think, one of the biggest barriers is the planning and approvals process, which has been a significant issue in many of the developments of hydrogen stations in the past. It can take, for example, in London we had a year delay in the planning process for the station, so this can have a significant impact on hydrogen buses and the future of the hydrogen bus operation. The last point is training of operators. I think this is here to say that this is not too much of an issue. In London we have people refueling the buses who also clean the buses. They're not specialists. They have no specialist knowledge. They've just been had a day training, and they happily refuel the buses without any problem. So I think the training of operators has shown to be acceptable, but it's something which should also be addressed in projects. And as I mentioned, we also have a helpline within Chic to speak to Ashok Khosrogi from InfraServe, they are responsible for the Frankfurt station. So if you want to speak to someone directly from an infrastructure provider point of view and ask questions about technical details, then you can also contact Ashok Khosrogi or his colleague as well. So the telephone numbers are in the presentation. Okay, if there are any questions.
Ulteriori domande su questo tema? Altrimenti chiedo di utilizzare questi mezzi di informazioni che offre il progetto CHIC. Vorrei anche riferire all'obiettivo del progetto in corso adesso anche in Imperia, che sta cercando di creare i centri di eccellenza che stanno nascendo ovviamente in tutte queste città con progetti di questi bus. Magari possiamo concludere with the video of Cologne that was recently granted another 2 buses that will be in operation in Cologne. These are a bit longer buses, so these are 80-meter buses and look a bit like trams too, with a very specific design. Yeah, let's show that, and afterwards we'll show you the website.
How do I make it large?
Was there another? Yeah? Okay, sorry, there was one more question.
One question. During refueling, do you have data transfer with the tanks and temperature, pressure? Because on the buses while you're refueling, and what flow do you achieve in refueling?
Okay, so we don't have a communication fill in London. Some of the other projects do. We have a computer system that sits next to the station which reads the ambient temperature and obviously monitors the pressure from the station. So we receive all the information from the refueling station provider about pressure and temperature from the station, not from the bus. And we have a flow meter, which I will say has been a problem. We have the flow meter is today. I think they're not very accurate, and there's still work to be done on how accurate the flow meters are. If you're going to charge people for fuel at lower quantities than a bus depot. In terms of refueling time, we refuel and we work this out. We have it's about 15 kilograms. I think it's about 34 bar a minute. I have to think about it in my head. So if that sounds about right, yeah. It's not very high in London, but what we have in London is we have what is called a TK16 nozzle. It's compatible. It's designed to be compatible with the cars, because originally we planned to have some cars as well. If we were going for to improve the station, we would change the nozzle for a bus-specific nozzle, and that would improve our flow rate and our refueling times. But we refuel in 15 minutes, so that's acceptable for us.
Ok. Allora chiudiamo con questo video da Cologna, che è anche molto affascinante, credo, per vedere come operano questi bus lunghi.
Can I make it large, Monica? Or can I just play it embedded?
Maybe not. I'm not sure if that's. Yeah.
If I press play, will it be loud?
Yeah.
I'll try.
Mobility is an increasingly urgent issue nowadays. Growing numbers of people want to, and indeed must, become even more mobile. But this growing demand for individual mobility is now rapidly overloading our traffic systems. The solution, which has always been obvious, but is set to become more incontrovertible than ever, is public transport, relieving the pressure on our roads and environment as it does. But V.LO is going a step further. Our goal is modern transportation which helps protect the environment. using the emission-free energy source of hydrogen. That is the future of public transport. It's a big step, and one which can only succeed if resources are pooled by the companies involved, policymakers, and local authorities. It all started in Hürth in 2005, when the regional innovation network V.LO set itself the target of making intensive use of hydrogen as an energy source. The presence of the local chemical industry there meant that conditions were ideal. For the industry, hydrogen is a byproduct which is already available for reuse and cheap. Fuel cell hybrid buses are not yet standard products, which is why the V.LO partners have invested so much effort in the last few years and carried out tests on different platforms. And here finally is the result. May 6, 2011. In a national press conference, RVK's first fuel cell hybrid bus was introduced. Attended by a large number of both local and national political and business VIPs, the maiden voyage started at the central bus station in Hürth. But it was quite a long way to get there. Production of the first fuel cell hybrid buses for RVK began in 2009. APTS, Advanced Public Transport Systems, based in Helmond in the Netherlands, is located in one of the main centers of automotive development in Europe. The bodies and technology of the vehicles are given tangible form in the computer. Here the buses are being planned and designed right down to the finest detail before actual assembly begins. This is how it all starts. The body shell. The bodies look like this when they're delivered and are then fitted out to order. Intelligent production management and perfectly coordinated logistics allow certain processes to be carried out in parallel. This reduces construction times and increases efficiency. Like any other vehicle, the fuel cell hybrid bus requires basic electric cabling. Everything is checked and tested in line with the specifications. But this is where the first difference becomes apparent. The tanks. For the hydrogen. For the fuel which provides the energy, but with zero emissions. Here too, safety is the top priority. This is why the hydrogen tanks and tubes are subjected to special 435 bar tests by the German TÜV Safety Standards Authority, 1.5 times their rated value. It looks like a simple, inconspicuous black box, yet it's the heart of the entire energy system, the fuel cell. The energy stored in the hydrogen is converted directly into electrical energy here. And these are the components of the fuel cell. First, the anode, which the hydrogen is fed to. And opposite, the cathode, to which oxygen is fed. Between them is a membrane. Finally, there's an appliance which consumes the resulting electricity. If hydrogen is now fed to the anode and oxygen to the cathode, an electric current starts to flow, which can supply electrical energy to an electric motor or can charge up the bus's batteries. The key advantages of this reaction are that the entire system is 5 times lighter than batteries and that nothing other than pure water is created during the generation. Now the energy generated needs to be put to work. by means of an intelligent energy management system. The energy management system has been developed by a high-caliber research joint venture between the Cologne University of Applied Sciences and RWTH Aachen. The bus's entire electric drive system has been faithfully reproduced here in Cologne, so that all the technical details can be specified and tested with maximum precision. All the typical test cycles for daily operation of the bus are subjected to rigorous checks. Once everything has been optimized, the software is uploaded to the bus where it's ready for use on the road. Batteries and high-performance capacitors, or supercaps, are fitted alongside the fuel cell to provide power. In a normal bus, the kinetic energy generated during braking is converted into usable heat. The V.LO, by contrast, has special brakes, which can turn the kinetic energy into electrical energy each time the brakes are applied. The current is generated in a similar way to a dynamo and can then be used when the bus sets off and accelerates. The supercaps are primarily there to take care of the peak loads. The batteries are responsible for the mid-range load for normal driving situations. The fuel cell functions like a base load power plant, recharging the batteries and supplying current for short-term storage. Coordination of the individual components in the highly complex energy management system demands maximum vigilance from all concerned. Setting up, taking measurements, checking, comparing values, final programming. This is the moment everyone has been working towards. All parts of the drive technology are now working together. The air conditioning is also mounted in the front section of the roof, alongside the battery and the control technology, ensuring a pleasant temperature in the passenger compartment, which is what's now being completed. Putting the